Welcome everyone. So we have in this question we have a nice little problem on series, geometric series to be precise. So we are going to solve this series. We have to find out the value of x or values of x if there are more than one. So on the right hand side of the equation you have a series, and I am going to write this series as 1 minus x plus x square minus x cube plus dot 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 till infinity. So this is a sum of infinite terms of a geometric progression, and we know a formula which says that sum of infinite terms of a geometric progression is a upon 1 minus r, where a is the first term and r is the common ratio. And there is condition which must be met, which is mod r, absolute value of r should be less than 1. What does it mean? It means that let us quickly see, r should be either less than 1 or r should be either greater than minus 1. Now on number line, if you see these two things, you will see that minus 1 is here and 1 is here. So value of r should be greater than minus 1, so it should be here on this side, or less than 1 means on this side. So r should lie in this interval. If r won't lie in this interval, then what will happen is the question. Suppose r is somewhere here and this value is 2. So if r is equal to 2, what will happen? Let us take a simple series s infinity of 1, first term is 1 and then you have 2 and plus 2 square plus 2 cube and so on. So this series will blow up to infinity. If you will add more and more terms, see every term is becoming greater than the previous term. So you will add more and more terms, you will make greater sum in the end. So as you add infinite terms, the sum will approach to infinity. And if r is in this range here, suppose r is here, which is minus 2, then what will happen? Then the same thing will happen, but the series will approach to minus infinity. Okay, so that is why r should be between minus 1 and 1. Now let us find out what is r in r series. So first I will rewrite r series like 1 plus minus of x plus minus of x square plus minus of x cube plus so on till infinity. So in this series, this is s infinity. Okay, so in this series a is 1 and r is equal to, r is found by a2 by a1 or any two terms, consecutive terms. So you have minus x over 1, which is equal to minus x, which is equal to minus x. So here you have r is equal to minus x. Now r range is already given to us. R should lie in this range. Sorry, less than 1 and greater than minus 1. And r is what? R is minus x. So minus 1 greater than minus x less than 1. So if we change the sign, we will get 1 and the operator will flip, and then you have x and then you have minus 1. So x should lie in this range. X should lie in this range. Okay, now let us sum up the series. S infinity is equal to a upon 1 minus r, which is equal to 1 upon 1 minus minus x, which is equal to 1 upon 1 plus x. But on the left hand side of the series you had x. So actually you had x is equal to 1 minus x plus x square minus dot 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 till infinity, and this part we have already calculated as s infinity, which is equal to 1 over 1 plus x. So from here we have x times 1 plus x is equal to 1, or x plus x square is equal to 1, or you have x square minus x plus 1 is equal to 0. Now it will give you two roots. X will give you two roots, which is minus of minus 1 plus under root of minus 1 whole square minus 4. One moment, I made a mistake here. Actually this quantity is minus 1. X square plus x minus 1 is equal to 0 is the correct equation, not this one. Because if you change this equation, you will get x square plus x minus 1 is equal to 0. So this is the correct equation. And now let us find out the value. So you have we have to cancel it. The first value is minus of 1 plus under root of 1 square minus 4 into a is 1 and c is minus 1. b square minus 4ac, we are using the quadratic formula, upon 2 into 1. So which will be minus 1 plus root 5 upon 2. The second value is very easy, which is minus 1 minus root 5 upon 2. So we have two values of x. Sorry for the mistake. One value of x is minus 1 plus root 5 upon 2, and second value of x is minus 1 minus root 5 upon 2. Now we need to find out whether both the values are acceptable or only one of these are acceptable. So first we need to find out what is the acceptable range of x. Acceptable range of x is written here. Let us see it on the number line. X should be greater than minus 1 and less than 1. So this says that this is minus 1 and this is 1. Something which is greater than minus 1, something which is greater than minus 1 here will obviously move this side, and something which is less than 1 will move this side. So we need values lying between these two barriers, boundaries, or you can say this interval, open interval minus 1 to 1. So let's check out the first value. We know that root 5, there are two methods to check out whether, if you remember the value of root 5, which is around 2.23. So 2.23 minus 1 is 1.123. 1.23 upon 2 is a positive number which is less than 1. So which is obvious that it is a correct value. But mathematically, if you want to find out, then you can say root 5 is less than root of 9 and root of 4. So we can say root 5 is less than 3 and more than 2. So root 5 minus 1 is less than 3 minus 1 and more than 2 minus 1. So 1 upon 2 is here, and then you have root 5 minus 1 over 2 and less than 2 by 2. So this value of x, this is the value of x, lies between 1 and 1 by 2, which is 0.5. So this is acceptable. This is between the given range, less than 1 and more than 0.5. 0.5 is suppose here, then we are getting this range of x, this value. So which is inside the prescribed range. Okay. Now let us see the second value. X is equal to minus 1 minus root 5 over 2. Now we have we already established that root 5 is less than 3 and more than 2. So minus root 5 is less than minus 2 and more than minus 3. And minus 2 minus 1 less than minus root 5 minus 1 greater than minus 3 minus 1, or you have minus 3 by 2 less than minus root 5 minus 1 by 2, and you have minus 4 by 2. So you are getting x second range of x, which is between minus 2 and minus 1.5. Now something which is greater than, where is minus 2 here on the number line? Minus 1 is here, so minus 2 is here, minus 2. Suppose here it is minus 2. Then minus 1.5 is in the midway, minus 1.5. Okay. So x is greater than minus 2, so x will move this side, and x is smaller than minus 1.5, so x will move this side. So we are getting this range here, which is outside the prescribed range. This range is outside the prescribed range, so this value cannot be taken. So the only valid value of x that we are getting inside the prescribed range is x is equal to root 5 minus 1 over 2. And this is your final answer. Thanks for watching the video. I hope you have understood the concept of infinite GP and how to find the ranges and all. If you have a doubt or if you want to improve this solution, please let me know in the comments.